Okay, so I'm going to just quickly go through setting up a linked list in Java to give you guys an idea with your code tasks. Okay, so there were a couple of things you need to do. So number one, you need to make a new project or linked list, which you can see that I've done over here. All right. The main method must create a new object from the constructor. So you can see my public static void main. I've just done linked list ll equals new linked list. So I've got an object called ll, which is a linked list. And then I had to set up a constructor. And so this is my constructor. All right, over here. Remember, how do we know that a method is a constructor? The method name is always exactly the same as the class name. Okay, so my class is linked list and my method is called linked list. Now remember what we said, a linked list is a dynamic data structure, has a pointer to the head. So there are my two pointers. Remember, we have to have a head pointer because we need to know where the head of the list is. And this is my cheat method for doing really quick adds, is to put it, have a tail pointer to keep track of where the end of the list is. So when you initialize the list, the head and the tail are both going to be null because there are no items in the list. Okay, and I'm just printing out over here, new linked list initialize, and I'm just going to check that my list is actually empty because I've got an isEmpty method which basically returns if the head is null or not. Okay, this is the same as writing if head is null, return true, else return false, if that makes sense. Okay, I'm just being lazy and writing it all in one line. And so you can see over here, when I run this, it's going to tell me that new linked list has been initialized and the head is null. Okay, true. So the next task is to basically, oops, I just dragged some stuff around over there. Right, the next task is to create a class list node to represent the node type. Okay, well, you probably want to have a look at my list node class. All right, so my list node class over here. All right, I have a constructor where I basically passing in a payload and I set the global payload to be whatever I'm passing in. All right, now remember what is in every node, a payload and a pointer to the next item. All right, what is the next item? It's a list node, and so basically the data type of what my next pointer is list node. All right, because that's what it's pointing at, a new node. All right, so remember a node consists of a payload and a pointer to the next item in the list. That's all my list node class is. So, right, what's going on over here now, right? So the next thing is I want to, got my constructor, which I've done, okay, a head pointer, tail pointer, and everything needs to be null, all right? So add methods to, so let's go, for example, print the list, okay? So let's add a new method in here. All right, so we're going to have public void print list, okay, because that's going to print out my list. And so we can check to see if the list is empty, because if the list is empty, then basically I don't want to do anything. So it is empty, and if it is empty, I'm just going to move this entire line out of there, because what's the point of having it over there? Stick it in here now. All right, system.out.println line, the head is null, and if it's not null, then I need to print out all of my items in the list, isn't it? Okay, so while, or let's start off with, so list node current equals the head, and then basically while current is not equal to null, I'm gonna system dot, shall we just print it all on the same line? It will probably be neater if we did it like that, isn't it? Well, let's actually just, I want to just do it all on separate lines, and then you can figure out yourself how to concatenate it neatly onto one line. So system.out.println, and I'm going to do current dot payload, and that will print out the payload of that current item, as long as the node that we've got to isn't null. So basically, when we get to the tail item, oh, well, we need to move to the next item, isn't it? So current equals current dot next. Okay, so we'll go to the next item, set that to be the current node. So obviously when we get to the tail is null, current becomes null, we loop back around, and well, it's null, so therefore we don't print anything out. Okay, if we want to test this out, let's see what happens over here. So ll dot, oh, sorry, I can't do my constructor, I'm in the wrong place, it needs to go up here, isn't it? So ll dot, and then there's my print list method. So ll dot print list, and it should come and tell me that head is null. Okay, or we can say, yeah, I mean, it's up to you. There's no point calling it twice, the is empty method. Now the next task says going to have a method to add at the head. Okay, so I'm going to assume that we're going to have a method over here, and it's going to be something like ll dot add, right? And we want to add, remember the payload of my nodes is a string, so we're going to add me, okay, to the list. So public void add, this needs to basically have a payload, so string payload. All right, now let's think about what needs to happen. All right, first thing that needs to happen is check if empty. Yeah, if true, then the head, so if it's true, then the head becomes a new node. Else, what needs to happen, we add a new node to the end of the list. Okay, so check if empty, that's pretty straightforward. Yeah, if is empty, we're going to use my isEmpty method, which returns a boolean. Let me just put my comment over here so you can see it. All right, so where's my isEmpty method gone? Just to remind you, if it is empty, then I'm just going to check the head. If it's empty, I return a true or false. Okay, so if it is empty, the head becomes a new node. Okay, so that's pretty straightforward. Okay, head equals new list node, like that. Now, if you remember, with my list node, my constructor it's expecting to receive a string because it needs to set the payload every time we create a new node. So that new list node is going to tell me, oh, capital N to begin with, and it's going to tell me that it's got the wrong number of arguments because it requires a string. However, there's no argument to be found. So whatever payload I'm passing here is what I'm going to pass. So that payload gets passed into this add method. The same payload then gets passed into my new node. And then my new node says, right, let's take that payload and let's stick it here as the global payload for that node, and it will therefore be stored. All right. So else, well, now we've got to handle what happens if, okay, there is already something at the end. Well, what we need to do is to put it at the tail. Now, we've got a problem over here because if it is empty, actually the head and the tail are going to be in the same place. So what I need to do over here is just say tail equals head, like that. Okay, so what I want to do over here then instead is I want to say tail dot next equals a new list node, okay, and that is going to accept the payload. So this is basically getting that null pointer from the tail, sticking a new list node onto it, so the tail now points to that new list node item. I'm not worried about the end of the list not having a null pointer, because by default when we create this, the list node.next is going to be null. But if you want to be absolutely sure about it, you can say next equals null when you initialize that node. Now I've got one other problem over here, that the tail still points to the original node that was at the tail. So if you imagine over here when we made our first node, the tail point at the head. Well, I said tail.next equals a new list node, so that's great. The tail is actually pointing at something else. But the tail pointer itself is still pointing at the old previous tail. So what I want to do is say tail equals tail.next. So I'm going to follow the next pointer of the tail, get the node that that's pointing at, and store that as the new tail. Okay? So let's check if that works. All right, so new linked list initialize. Let's do, so we've done ll.add Mr. Palmer. Okay, and let's do ll.printlist again. And then let's add another ll.add, and let's add something else. So let's add, I don't know, samosa, because you know everybody loves a samosa. And let's print that list one more time. And let's run this and let's see what happens. Right, so come on, drag up. There we go. The first time we ran it, okay, print list, we got head is null. Then we added Mr. Palmer and we printed the list and it printed out there. And then we added samosa and we did print list again and it printed out those two things. Now if you don't believe me, all right, let's add a breakpoint over here. Okay, and let's hit debug and we can watch what's happening. Right, so here we had our linked list. It's been created. Linked list has a head pointer. The head pointer contains a payload, which is Mr. Palmer, and it has a pointer to the next item, which is currently null. It also has a tail pointer, which points to the same list node, okay, number 98. Okay, now let's step into the so list.add. We're going to see, is the list empty? Right, no it's not. It's going to jump down here. Well, it's going to check to see if the head is null. The head is not null, so we're going to return a false, and so that's going to jump down here. So tail.next, right, so tail.next is going to be equal to a new list node payload, right? So that's going to then create a new list node. It's going to set, oh great, right, so it's created a new node, right, number 117. It's set the payload for that. We know the next pointer is null, right? So you can see, right, let's expand this again. The tail there we go. So we've just done tail.next. So tail.next now points to this new node 117, which has a payload of samosa, okay, and its pointer is null. But the only problem is the tail itself is still pointing to the old tail. So this is this line over here where we're going to say tail.next, all right, is going to be stored as the tail. So let's step into the next line over there. So now the tail actually now points at samosa, okay? And if we expand the list, you can see the head points to the original head node, Mr. Palmer. It has a pointer next. Next points to the next node along, which was number 117, which is samosa, okay? And you can see that the tail is also now pointing at that same new node because we got the next pointer of the original tail and then stored that node as the new tail. Okay, so just to help you out, one last thing, okay, is right this idea of printing all of the items in the list. Okay, so you can use this idea of checking a node, or you can, so you've got a loop to until you get to the end of the list. Okay, bit like a serial search. So when you now are going to go do this next task up here, which is to add a specific index, you got to start thinking about using a serial search. Okay, or you could even use a for loop if you want, and you can loop through the list until you get to the specific point that you want to remove an item from, i.e. you don't stop at the one you want to remove, but you stop at the one before, because you need to use the same technique as this, where you can set the current.next to be equal to the current.next.next. all right, because then it means that the next point of where you're at is now going to point at the next item along, 2 items along. All right, have a bash at those programming tasks and see how you get with them.